Hi guys, welcome to the 8th riddle in the Flare On challenge. So this time we're doing some NES reverse engineering. They supplied an NES image with a little snake game, and you have to solve the game. Now I didn't really try solving it because I thought it would be too hard anyway, so I started searching for a way to make the game believe that it is solved, though it isn't. After searching for some magic strings and trying analysis with Ghidra, I found out that this won't get me anywhere. Ghidra was able to decompile the application, however, I was not able to derive anything useful from the decompilation. So next I searched for an emulator that was actually able to play this image. And I came across this great one, which is called Mezen. And it's not just an emulator, it's also a full-fledged debugger and IDE for NES development. So with this one I thought I might be able to do a dynamic analysis of the target. If you're dealing with older gaming consoles or home computers like the Commodore 64, you often have a concept of character sets and sprites. The graphic capabilities of these machines weren't strong enough to render full graphics on screen, because memory was too limited and the processor was too slow to copy the data over. So there was a concept of character sets being used. So you don't have a character set with regular letters inside, but instead you have images that are composed in a 2D array to give the illusion of a bigger image. And this is what's happening on the NES. You see that the whole playfield is actually just being characters placed in a two-dimensional array. In addition, you have sprites, and sprites are small parts of graphics that can freely be placed on the screen. And I found out that the apple that the snake is going to eat and the head of the snake itself is a sprite. Now you may wonder, why not do these as characters as well, and probably the reason is that most of the time with sprites you get some mechanism of collision detection, so it's easier to find out whether the head hits the apple. Probably because of projects like Mezen, the inner workings of the NES are documented pretty well. So here's a wiki entry that explains what the graphics API looks like. As you can see, you have two memory locations at 2006 and 2007, which allow you to communicate with the PPU, which is a gateway to the graphics processor. It's not uncommon for older systems to have such a fixed memory layout like this. When I started programming, it was a Commodore 64, and there it was exactly the same. If you wanted to play sprites or characters or something, you had predefined memory locations where you put the values of the offsets of where to display this stuff. Like a regular debugger, Mezen allows you to set memory breakpoints, and you can also specify whether the breakpoint should fire on read or write. So I went ahead and set a breakpoint on the locations that set the sprite position and chose write access to find out the location in the program where the sprite coordinates change. With this I found out that the memory fragment right at the beginning at address 0 seems to contain all the program state, and my assumption was that the current length of the snake would also be stored somewhere in there. So I played a while and had the memory view besides the field, and I really noticed that one byte there corresponded to the length of the snake, so each time I was eating an apple, this value increased by some points. Then I set another memory breakpoint on write to see when this value changes. And with this I found out the routine where the snake gets longer and where it's calculated whether you have solved the game. And with this I was able to switch a condition to make the game think that it's solved, and this gave me the flag.